Hi everyone, this video is for my CS6250 course assignment on NeRF and Gaussian Splatting. I will quickly show how I install NeRFStudio, process my video, train the models, and export the result. I first tried installing NeRFStudio directly on Windows, but I ran into a tiny could have built error during installation. Because of that, I switched to using WSL and follow the official installation guide from NeRFStudio's website. The installation worked smoothly in WSL and it gave me access to all the NS commands. If I go to the installation section on the NeRFStudio, it gives all the steps that need to be followed to install properly on Linux and Windows. Windows. In the official NeRFStudio website, there is uh, detailed steps on how we can train the model with they also provide how we can use their existing data from using existing database. Like if we want to use the custom data, we can see using custom data section, and we can see that it supports different type of data like images, video, polycam recorded from iPhone with the LiDAR on, and they come with different data, other data types and formats. Like before we can begin training, we need to convert our custom data into the suitable format for the NeRFStudio. And to process data, we need to use NS process command. If we go to the command prompt and type NS process data, and then we need to specify with what kind of data we are going to use, like image or video. For my case, I have click the video from my phone and I'm going to use that as a training data. So I need to specify it as video and then provide data folder. I need to give it the path to my data. I have path stored in my data slash ARC folder, and then I need to give the name for the video. I have set ARC, that's all as video name, and its extension is MP4. And then I need to specify at what directory I want to store the outputs of the data that it is going to extract. And for that, I need to use output directory, and I want to keep the same data in the same directory, so I'm going to use data slash arc. If I press enter, it will begin extracting frames from my video. Like I have total number of 1690 frames, and it extracted 338 frames in evenly spaced intervals. It has done converting video to images, and it is running CallMap feature extractor. CallMap extracts the camera position from the video, and it takes around 5 minutes. So let me pause the video for now. While CallMap is running, let me show you the input video that I used to train the model. If I click on the video, yeah, I used this video to extract the features to create a 3D model. I use this video to train the model. Call map is still running. So let me pause the video for some time. Now the call map has finished extracting camera position. It's been able to extract camera position for around 42%, 9 percentage of the images. Uh, this isn't great, but maybe okay. It gives the reason that it couldn't extract all camera position because of poor scene coverage or blurry images or large exposure changes. It's been able to extract 100 camera position for 145 images out of 335 images. Now we can see that the data is in the data arc folder that we have specified here. Now I can use this data to train the model. To train model on NeRFStudio, we can use train command, and we need to specify whether we are going to use NeRF or Gaussian splatting. To determine NeRF, we can use NeRFacto, and for Gaussian splatting, we can use splat factor. I'm going to train NeRF first, so if I click NeRF, if I type NeRFactor, and then I need to provide the data folder that we have currently extracted using call map, and the data is in data, and the folder is data slash arc folder, and if I press enter, it will begin training our first NeRF model. It comes with a web-based visualizer. We can see that there is a link for the visualizer at the bottom of the command prompt, and if I we can see that the training has already begun, and it takes around 15 to 20 minutes to train a NeRF without visualizer on. If I open the visualizer, it almost takes double time. I don't know why, but if I click on this link here, it will open the web-based visualizer and Chrome. We can see in real time that the NeRF is currently training on our data. The NeRF is being trained, and it takes around 20 minutes. So let me describe the renderer it comes with. By then, it has training speed set in here. We can set slow, medium, or fast. Let me train in the fast mode, but it doesn't hinder the render quality by the end of the training. So it can be used to render a video. Like we just need to add a keyframe on each camera frame to render video. Add keyframe on this camera, and we need to add more keyframe. Let me add. I think it's just training, so it's giving actually slow now. The estimated training time is around 26 minutes, so let me pause the video for now until the training is over. Now the training on NORF has been completed. Its config file is saved in outputs folder, which can later be used to visualize the trained model. And now we're going to use the link again to see the visualization. If I click on the link, it will open the visualizer, you can see that the training and console has already been completed, but it's not been loaded in the browser yet. I can hide the training cameras. These are the training cameras. I can just hide it so that it can be viewed easily. It can the resolution of the model can also be increased, so the resolution slider here to increase the resolution. Again, it looks better. Now the node training has been completed, and we can see that the 3D model has been constructed on the web visualizer. We can I can move on the scene with keyboard. Like if I press W, it moves, it translate forward. W is used to translate forward, and I can use S to translate backward, D to translate on right, and A on the left. I can also change the camera position with the arrow buttons, like up, look up direction, in left or right, and the mouse can be used to rotate. Do that, like look up or down. I don't know, but why it takes lot of time to refresh the new lookup direction. Like if I change the lookup direction, it needs 6 to 7 seconds to load properly. It could be the issue with my computer. It might be dependent on the computer. If I look in the up direction, it looks kind of blurry. If you, I, I believe that it is because of the less number of camera positions. Let me decrease some resolution so it can load faster, I guess. Yeah. Yeah, this is what the NeRF look like. Now let me train the same data set with the Gaussian splatting. For that, let, let me close the visualizer first. Then I need to press Ctrl C to exit from here. Now I'm going to train this Gaussian splatting with same data. ns train splat factor, and then keep the data directory with data flag on, data slash arc. If I press enter, it will begin training Gaussian splatting, and it just follows the same process again. It will provide now the training heads. started, let- the Gaussian splatting training is a lot faster than the NeRF one. It is displaying around 45 minutes to train the model. Let me open the visualizer so that we can see some live training. It's training the Gaussian splatting. It's hard to see like the NeRF in live training. Let me reload. It's not showing yet. The time has increased from around 4 minutes to 10 minutes as I open the visualizer. So let me close the visualizer for now. We'll come back after the training is finished. So for now, I'm going to pause the video. Now the training has been completed, and I'm going to open the train model on viewer. It takes some time to load the model. We can see that it is faster than the NeRF in terms of loading data. If I increase the resolution, it updates a lot quicker than NeRF. If I move forward, I think for some reason it is not able to construct all the scenes correctly. It could be because of the lack of proper camera positions. Even able to reconstruct most part of the ARC Atrium. Let me zoom out and zoom in. Can look down or look up. Translate forward. Now the train model can be rendered as a video by adding a creep frame to the scene. Like I need to select the camera first and then add it to the keyframe and then select other cameras to add as keyframe. Add keyframe. It will show the Bezier curve like this, and then I can play the video and to preview render. I just need to click on preview. This is what the render video look like, and it can be exported as a video by generating command and running the command through command prompt or a terminal. And it can also be exported as a mesh. If I go to the export button, it will ask to select. Currently the mesh export is not supported for the Gaussian splatting. It is only supported on NeRF only. This is how the video look like. Now if I exit the render, I can add more camera frame to the keyframe, and if I add the keyframe, add to the keyframe, then you can play and then preview render. It will render video more. Let me try to show the two results side by side. Let me add another power cell and type WSO and activate NeRFStudio, and then I just need to type ns. Sorry, I need to copy this. Let me open terminal directly from the folder. Terminal and WSL, go and activate NeRFStudio for the conduct environment, and then I need to go to ns viewer, and data is in my, I need to load config. I have already trained that model, so I need to load config outputs slash. I have ARC folder, ARC, and then I need to go to the nerf factor folder, the folder name timestamp folder 2025 December 4 slash. Inside that I have a config.yml folder. I just need to type that and it will start the new viewer for the nerf. If I click on the localhost, it will create. Now let me take side by side. Increase resolution. As you can see that the loading of NeRF takes a lot of time as compared to that Gaussian splatting. Let me select the same frame. Let me hide the cleaning can. As you can see that from a similar position, North makes it looks like the blurry, but Gaussian splatting leaves whole like artifact in its scene. Let me go back a little bit in here. I see that Gaussian splatting of this really fast. But the nerf is pretty slow. I think that's all for my NeRF and Gaussian splatting assignment. Thank you for watching.